Okay.
Well, we do have another panelist that is probably just enjoying his final bites for the speaker's dinner. So might as well let him enjoy it. But this is a panel that we wanted to sponsor at the CppCon. John and I were passionate about spreading the word of C++ to the whole world. And one of the ways of doing that is through user groups, to support people throughout the year to get a better understanding of what the language entails. And since we're local, we wanted to do something where we would have some panels where you could come and ask questions and get some answers about different topics. And so tonight we wanted to do something about C++ and Internet of Things. And so we have a panel here, and I will let them introduce themselves. But I will say this is an open question forum, so please go to the mic and please ask questions. This is not like any formal presentation or anything like that, so enjoy.
Hi, my name is Sarah. I started a company called JewelBox. We make smart friendship bracelets for young girls.
I'm Dan Sachs, and I'm supposed to know something about C++, I guess. I'm Lloyd Moore. I've been working as a consultant in this field and professionally for about 30 years, robotics and all kinds of other stuff.
Let's make sure this works. My name is Jelani Brandon. I work for Microsoft Azure IoT on the C SDK.
And I'm Everton, and I work with Giovanni at Microsoft on the same team.
Well, one of the panelists gave me a question to ask, so I will start it off. So how would you define Internet of Things?
I gave you the question, so you guys ask.
Okay. Well, I'll take the first stab at it. It is when you say IoT, most people look at you and say, "What is that?" And I say it's a little bit of everything. It's any connected device to the internet that achieves anything you need for it to achieve. So I tell my wife, well, the refrigerator could be connected to IoT, and the toaster, and everything could be IoT, and she glazes over. So it's anything that is connected to the internet.
Yeah, this is interesting because sometimes I talk to people I used to work with in Brazil, and I say, I'm working with IoT right now, and we had some good interaction with Samsung and Philips, and we had this refrigerator working with the cloud and everything. And the first question they have, oh, you're working with appliances now. And it's kind of very hard to come out of that because people don't have an idea, the average people don't have an idea that IoT can be like on automation and industry and so many other things, right? But the first thing that comes to mind is that refrigerator that shines at Home Depot. So it's kind of hard to sell the right image, but yeah, it's interesting.
This is sort of a statement, but it's coupled with a question to see what your reaction is. When people ask me what's an embedded system, I generally say it's a computer that isn't a computer. In other words, it's a device that you look at it and you don't identify it as a computer, but it has computing capabilities inside of it. That's what makes it embedded. And when we talk about the Internet of Things, well, we've had computers on the network for a long time, and we never called them IoT. I think it's one of the characteristics of what we're calling IoT is devices that you look at and you don't say that's a computer, that's something else that happens to be on the web. Is that consistent with your view.
I'm interested by your definition, because by your definition, these guys use Bluetooth. They use Bluetooth, they talk to other devices, and they talk to your phone. But right now, they don't talk to the internet. So that would make them a non-internet of things. Make a, of things.
Or it's the internet of nothings.
Maybe that too.
So I actually kind of seeded this question with Brett when we were talking about this, and it came from a discussion we were having among the consulting group when we were trying to define this for ourselves. And basically, we really couldn't really pin it down. It's, to us, it was essentially anything that's a computing device that's connected to a network. And some of the things we've done involve Bluetooth devices connected to a gateway that go onto the network. So it's literally anything, for us it was the refrigerator, the Philips Hue light bulb, the Alexa and Google Home devices, watches. It's a very, very fuzzy line is kind of where we were at.
Okay. What do you want to add? Do you want to add to that, Arthur?
I want to ask a new question.
Okay, go ahead.
So you two guys from Azure, you say you work on the C SDK.
Yes.
Why don't you work on the C++ SDK?
That is why I said the C SDK. I'll answer it and I'll let Everton chime in to see. When we first got our charter to work with Azure on the SDK, we had religious wars about whether we should go with C or C++ SDK, whether we should have interfaces or have a wrapper over a C. And we came down to the reason we went to a C SDK is because we went to the least common denominator. Because we wanted to fit on the smallest devices we can. We have embedded boards, we have Arduino, and we wanted to make it portable for all those devices and not have portable code. Now, a lot of the customers we have, they take our C SDK and write C++ over our SDK. Matter of fact, 90% of them do that. So we wanted to not constrain people from using C and have them in C++, or C was the least common denominator that we went with.
But are you actually compiling internally in C++ and then extern C'ing some interfaces, or is it C all the way down?
It's C all the way down to the base.
Yeah, and that's exactly it. And we didn't want to have duplication of the code base, so it would be complicated for us to keep C++ and keep the C, which some devices like Embed or some other platforms like Arduino, we really don't have a straight way to have more than the C99 running there. So, but we do keep full compatibility of C++, and indeed we use wrappers on top of our own C SDK that is used by other components. Like for people that are familiar with LibBoost, for example, we back our C SDK on a C++ API, and then we convert that to Python using a library for that. So that's why.
Okay, next.
So in 5 or 10 years' time, my fridge will be an Internet of Things device, my dishwasher, my furnace, my washing machine, my stove, and then there's Heartbleed 2. And it turns out the manufacturers or either no longer exist, or they haven't maintained that code and they're not patching it. What gives? Do I rely on my router? How do I protect myself with Internet of Things if it's not a $20 smart plug that I'm willing to just throw and buy a new one?
I'll take a stab at that because I also worked in the industrial space where we run into the same issue. This is a big discussion in the IoT space right now of, A, how do you do this? Because you want to keep the price of the device inexpensive. And unfortunately, adding security does raise the price. So there's a competing tension there. And how do you update this thing? Some devices are updatable and some are not, and there's not really a good answer I've seen yet for this. I think my recommendation at the moment is, it's connecting to the internet. Have a good router and run NAT inside, and I'll give you a little bit of protection. That's probably not a great answer.
What do you do with IPv6?
Yeah, exactly, yeah.
Well, the question is how much are you willing to pay for that device in order to make sure that it's secure?
That's right, yeah. And less expensive the device, the less secure it's going to be. So to your $20 disposable, the cheaper it is, it's going to be more likely to be disposable. If it's something like a Alexa or a Google Home device or a smart refrigerator or something that has fairly good monetary value to it, those are typically updatable today. So I'm going to guess that those will get some type of update. Now your question was, what happens if the manufacturer is no longer around or they're no longer supporting the device? I think that's an open question for the industry, and the question's being asked, and there's some legal ramifications around that too. It's right down to when a company sells something, how much of that are they responsible for in the aftermarket? And that hasn't been answered yet, at least to my knowledge.
Thank you.
At the risk of sounding like a Luddite, I used to be an early adopter of certain technologies. I like my food cool. I cannot imagine, why I would want my refrigerator to be on the internet.
Amen.
I can't. And so I would not, I would continue to buy appliances that give me the option of keeping it off the internet.
So I think one of the compelling reasons is you're down at your local grocery store and your fridge can tell you what you need to buy. As just that, there's the fridge and there's the furnace, if your furnace needs servicing, if your air conditioning unit needs servicing. There's a lot of great reasons.
It's generation.
But yeah, I'm your generation. Being a Luddite's not bad.
I think I'm actually on the Luddite side also, but it doesn't really matter if we are. We're going there whether we want to or not. So I think your question is interesting. I believe that we're going to have industries popping up to handle these type of questions. I think one's, our software is open source. I think a lot of things are going to be open source, and they're going to be like, oh, we don't support it, but here's the code, have at it. And then hopefully there'll be some type of network or some type of way that you can get in there and say, okay, I can fix it, or I hire a handyman who comes up and he actually fixes the code. So I don't know the answer, but I'm hoping that the industry provides this, that say, hey, I think I can make some money doing this and fixes your problem.
So we're going to be like plumbers.
Yes.
Isn't there a Linux plumbers come from somewhere?
It is. Which way did that be the question?
Oh, no.
I don't know. To me, when somebody talks about plumbers, I think Watergate.
Oh, I remember those days.
I think early adopters right now have a lot of really beautiful paperweights, and I think we've already seen that happen in a lot of early hardware. So it's kind of the risk you're taking.
Well, in the 90s, I was working on something to do this predictive maintenance on equipment, like you're talking, the air conditioners. But the problem is, people didn't want to spend the money. How much are we going to spend on the sensors and things like that? And the second thing I like to say is, we are not a panel of lawyers. We're a panel of programmers. So, next.
Okay. I'm afraid I'm going to change the topic. I'd like to first ask two questions just to get an idea of the panel and the audience. Just quick questions. Can I just have a show of hands? Who who is using sort of a real operating system like Windows or Linux or something versus real-time operating systems, you know, the little ones like Chevy OS or something. So who's put up your hand if you're using a real operating system? Alright. And put up your hand if you're using a real-time operating system, a little, okay. Alright, so it's about 50-50 maybe.
Yeah.
So then my other quick question is who's actually using C++ versus C on these devices? And then who's using C? Alright. Okay, so probably both. Okay. Okay, so then my question is, just give me an idea of what the answers mean. I would like to know your favorite method of handling exceptions or whether you work with exceptions. I know that it's totally debatable and there are a lot of ways of doing it, but I'm hoping to learn. I'm just hoping to learn, so if you have something you think is useful to say about how you could or should handle exceptions. Thank you, that's my question.
Why me?
Yep.
Tell me first, why do you worry about that?
Error handling is a big part of my job, so
But that's different.
I want to know, yeah, I'd like to see what other people are doing to do error handling. That's basically why.
There's many answers to that. It depends on the context. Just know that there are many alternatives to that. If you don't like them, the exceptions, you don't need to use them. Maybe apart from the constructors, if you care about that. So it's an orthogonal issue to error handling. It's part of the way you see things. I use them. They don't worry me. Some don't. It's really an orthogonal issue. It's a matter of taste mostly. Yes. If your system and your support doesn't help you along, do something else. There's, especially with C++ 17, there's many other options today.
I hijacked the panel. I wanted to say that exceptions are probably the right.
Where are you from? You unknown body.
Hi,
Speaking of an exception.
I will tie that back in a second.
That's an interrupt.
Yes.
I'm watching you.
I'm Owen Holmes. I work on tiny chips, bare metal systems, and some with a hard real-time component. And I have injected myself as an interrupt service routine unexpectedly into this panel because I mean I agree with Bjarne that there are many domains where exceptions are the right tool for the job, and they probably get a bad rap because they get compared for performance against code that just doesn't handle errors, and that's obviously going to be faster, right? But on the other hand, if you are not building on threads, if you are building on some other kind of kernel, like a preemptive run to completion kernel or RTFM kernel or something like that, where different tasks share a stack, then, and this is, if you're looking for just the best energy efficient solution, or the lowest jitter solution, or the solution where you can prove from a formal proof standpoint down to the lowest priority possible that you can reason about latency and starvation, then this is the right kernel to go for. And on this kernel, you share a stack, right? So you can't lock around the secret singletons that are everywhere, right? Like the heap is a secret singleton, right? Or locales are a secret singleton, right? And exception bookkeeping is also a secret singleton, right? There is some bookkeeping there that is shared with everyone on that thread. And if thread is a foreign concept, as in something with its own stack, if you have only one stack and you are interrupt service routining onto that stack at different priorities, one can interrupt the next, and interrupt the next, then either you have interrupt jitter because you're turning off interrupts at some point so that people can't inject themselves into your stack, or you are injecting yourself potentially into the throw of an exception. You can have multiple in flight even though you don't have multiple storage for that. Plus the practical problem that if you turn on exceptions on microcontroller, you're out of RAM. But that's an implementation detail that could probably be worked around. But people will pay 30% more for a microcontroller to save 2 instruction cycles of jitter, right? And you can't go and tell them, well, give up these 10 instruction cycles to do some weird compare and swap thing so that you can use exceptions on this I mean, there are systems where you cannot implement that. Statics in functions is another thing. The guarantee that it will be initialized only once is something you cannot really implement on those systems. So that there are architectures where it is completely legitimate to say, I cannot implement exceptions, which is why I think Herb is wrong for saying everyone must use exceptions.
What do you do instead, though?
Monads.
What
do you do instead, though, is the question. Well,
set jump.
It somewhat ties into another problem with exceptions, which is, on a thread, unwinding stack and going back in time to the point where I could deal with this is the same thing, right? Whereas if you're in an event-driven system, going back in time and unwinding stack is not the same thing. If you are an interrupt service routine and you throw an exception, and you do not have a catch in that interrupt service routine, then you essentially unwind into code that you interrupted. So you cannot reason about where an exception could be thrown because it could be thrown at a point where no one can throw because an interrupt interrupted there and through.
Yeah, but you won't do that, Odin, because it's bad form. Don't throw in an interrupt service like that. Don't.
I also want to say.
Instead, then.
I want to say
Don't
that
fail there.
you need to make sure that you're doing a lot of checking in your code so that you don't have to have an exception occur. You have to check for nulls. You have to make sure that memory management is.
No, you don't have nulls because you use non-null pointers. You don't have nulls in your code, please.
No, but you have to check for them.
And when the check fails, what do you do instead then?
Reboot. Well, actually, endless trap and wait for the watchdog timer to deal with it is one viable option on some systems. But yes, essentially, propagate through the return path to somebody that can deal with it. Maybe post some error message to some event queue. Maybe clear some event queue. It depends on the context, but essentially if you have a hard real-time system, error handling doesn't really play nice, so you kind of have to follow the strategy of proving that errors will not happen, like timeouts cannot happen, which kind of completes the circle, then you're an even harder real-time system. But correct by design because I don't have the resources to deal with errors is kind of a thing.
Standard optional can help a lot too.
Yes.
You cannot throw if you have to be signal safe. So don't throw an interrupt function, don't throw in a signal, you're not allowed to do that by the standard.
I must just agree with that. I don't think you should ever throw in an interrupt routine. But
You're
that's
not-
not a
you're
question,
not
that's
allowed
just, yeah. Okay. Thank you.
Oh, you very much.
I have another question.
All right. I'll try to ask something Alden has no clue about.
It doesn't matter.
All right. Okay. Whatever. So I might be remembering something wrong, but I think Bjorn mentioned something about how beginners learning C++ probably learn better if they actually deploy that C++ on some real stuff with good feedback or something like that. Do you think IoT in general is that kind of thing which could offer, because some students might not even know about the terminal. So if you do hello world, they're like, okay, I printed Word somewhere, what's that? What's that for? Do you think IoT is the kind of thing you could bring to someone who doesn't know programming, who doesn't know C++, and have them, just get that feedback, like, hey, I wrote a line and it moved an arm and opened a light or something.
Yeah, yeah. So that's kind of what we do, and I think that well, first of all, they're writing C++, but we abstract it out for them, so it's not like you don't have to think about memory or anything like that.
They don't write meta templates. Is that
No, they're not. But even, and I'd say Arduino is a kind of a gateway drug because it makes you think that you can build a consumer product, and don't ever fall for that. I did, and it's been 4 years of my life. I wouldn't trade it, but it's very hard. Yeah, when kids, especially when they see when they see that you feel like a god, right? You're like, when you make a little servo mover, you make something like this light up, you're like, oh my gosh, I did this. And like a see out is fine too, and you can see things print on, your computer, but it's just not the same thing as things lighting up or like a drone taking off or like anything like that to feel like you've done something amazing. So yeah, I think beginners writing like firmware is scary because firmware is really hard to write, but as long as they can write something a little bit easier than that.
I'll add to that just a little bit. I think whatever keeps them engaged. If it's a robot, fine. If it's turning on a light, fine. If it's talking to a server, fine. My nephew was about 8 years old and was seriously into Minecraft. And he wanted to set up a Minecraft server. And so go ask Uncle Lloyd. He'll tell you how to, set things up. And he's coming to me with details of how to set up NAT on his router. This kid's 8 years old. Don't limit them. Whatever keeps them going, whatever keeps them learning, good enough.
Some of you know that I have kids. I have 5. Fourth one is 10 years old. When she was 8, I brought her to school with me because she was kind of bored and there was nothing going on. And she used one of the computers. She installed her own server for Minecraft and started playing around without anyone's help. Just let them do what they want.
Did she write a redstone computer in Minecraft too?
I don't let her.
Yeah, just to add to that, I know a person that is like leading a program at UW right now, and she works with early childhood education, and her job is to train teachers, to teach teachers that teach young kids. And it's amazing that this person came to me the other day and said, do you know what is a makerspace? I said, yeah, I know what is a makerspace. So I need to know more about that. So why? And then this is what UW is doing. They're trying to bring technology to the kids as early as possible because they see that technology is where everybody is going. And in the future, all the things we hear about, well, if you know how to create things, you're going to have a more successful job in the future. So it's a very pressing matter right now to integrate that with the education from the beginning. And we had some discussions, and they were saying, well, are there other easier languages that they can use? Yes, absolutely there are. But one complaint that the teachers had was, when you come to the kids and say, you can program on this computer, their first thing is, I already use the computer. And I have other software that does a lot of other things that are more interesting. As soon as you put a Raspberry Pi there that shines a green light and red light, that's more interesting to them than a computer of anything that can put. So this thing about keeping the kids interested no matter what is really strong. The shining light really makes a difference.
Yeah. There's like tens of thousands of them on the screen, They don't see that.
If you had the CRT monitors, you could get really close and see the red, the red, green, and yeah, so, but not in this.
All right. Well, thank you.
So we've already seen that it's impossible to talk about IoT without talking about security or someone asking about it. Traditionally, C++ hasn't had the best reputation for security, but I think the language has done a really good job of fixing those issues with null terminated strings, null pointers, buffer overflows, those kind of things.
Adding a layer on top of the C subset.
Indeed.
The smart pointers.
Smart pointers, yeah, you could go on. But when we talk about IoT and security, the area I think C++ is lacking in is, if you look at a lot of other internet languages like JavaScript, Node, PHP, those kind of things, there's lots of tools for doing security analysis, especially as part of continuous integration. I'm not really seeing any of that on the C++ side, at least not yet. So do you think security is going to be addressed more by the language, or by tooling, or by something else? Or are we just giving up?
In C++, you mean?
Yeah.
Well, coming from the IoT space, it seems like security is usually, when you're developing it, it is after you're done, okay, what should we do with security? And regardless of language, regardless of methodology, I think the initial, if we start looking at security from the very beginning, is a part of the design, I think that is a step in the right direction. As I've come to find out, security is very tough. And the more you put into it, the more you're like, okay, I just want to get stuff done. I don't want to actually have to worry about having to do, these ports are open, and now I'm connected to the internet, and now who's going to connect back to me, and all. So I think the problem with security, whether it is built in the language, that it is a human problem and not a programming language problem.
Well, do we still have a typed IR working group?
You still have a what?
Do we still have a typed IR working group?
That's far as I know.
So I want to expand on what you were saying a little bit, because it's some of the security issues we're going to see in the IoT space are fundamentally different than what we've seen anywhere else. One case in point, we were working on a connected toy. This had a voice interface on it. This isn't really as much of a security issue, just as something you need to be thinking about. The voice interface, is designed to work with children. Children have a different voice profile than adults. The current voice recognition systems do not always handle this well. Just some of the things we saw coming back from that, where the speech recognition engine would misinterpret what the child said. It came back with a few they weren't even necessarily malicious per se, but things you would not want to say to a child. Okay, I'm not going to repeat them on stage.
Darn.
There was also an issue, I'm trying to remember what it was. It was a connected mirror or something where they were hacking the camera or something like that. The space itself opens up a range of security issues that are more than buffer overflows and denial of service attacks and all the things we're traditionally used to. So when we're talking about security, I think we need to include all the stuff we've been doing. Plus, we need to be thinking about what other things could go wrong, including things just with the system that could be perceived as a security problem that are not traditional.
Allow me to.
I was just going to say that when you said that the mirror got hacked, that was probably hacked by something like a buffer overflow. Unless they just hard-coded their telnet password, in which case.
Which just shows that you should stop doing C and start doing C++. If you allow me two facets, one of these is you're using C++ among other things because it's a zero cost kind of thing, so you don't want the language to do it for you. The other part is it's a systemic problem. So it's not a local property security, it's a global problem. At my lab, not me, but most of us, what we do is work with older people, people who have disabilities, and people whose brains are having difficulties and stuff. And we carry a lot of personal information on the network all the time. There's no language that's going to save you from that. Okay, so it's not a language thing, it's a systemic thing, it's a complex thing, it's a protocol thing, so it's completely outside of the scope of the language.
Yeah, but isn't there still like a feedback loop where the current set of language features are used to do certain things? People invent tools. Well, they see people probing and trying to pick locks, so then they invent tools to try to automate the detection of that. That provides a feedback, which then causes the language to get beefed up. And then the creative people figure out, okay, what holes are left in the armor? And it's a continuing cycle.
But then someone leaves his password on a post-it note.
Yes.
Yeah. Don't laugh.
Yeah.
I think this is going to sound really morbid, but this security with this kind of thing is different than like losing your credit card number on the internet, right? And like, so I was like telling the story before a little bit. So in the early 1900s, about dozens of people were killed by boiling molasses in Boston. And now every architect has to be licensed in every state and has to be on site and sign off on every blueprint in order to build a building, because the architects blamed the construction workers, the construction workers blamed the architects, and in the end it was like, we're not going to let these people make mistakes again. So I think when you have things like self-driving cars and cars with internet and your refrigerator tweeting and all these things, these are big things that can hurt lots of people, especially like when you have systems in hospitals like running on these things. These security things, like they're taking it back to the language, building it into the language, people are always going to find a way around it, especially when you're working with like tiny chips, right? And you're like, man, I can either make this thing like Snapchat or I can make it more secure. Well, it turns out the consumer wants you to Snapchat. So I don't know. I think that it's a little bit scary. So that's it, the end. Watch out for molasses.
So first a comment and then a two-part question. So this kind of gets back to Internet of Things, because I think there's a lot of things happening that's not necessarily internet connected, that's a little bit related to the security thing, where if you got all these devices at your home or you're talking to each other, you don't necessarily want them talking to each other, right? So what do you see happening, and what would you like to see, that's the two parts, in general connectivity, whether it's Bluetooth, other kinds of protocols, other kinds of connectivity? That's my two-part question.
Oh, that's a complicated one.
The Internet of Things is about connectedness. On my PhD, I'm a Canadian, so we have lots of open spaces. So I build all of my software presuming that there is no such thing. So I don't think I'm the right person to answer your question.
I like to see the things become the internet, like the like not having to use cell phones anymore and things like that, because we just have all these nodes everywhere. That would be really nice. It's another security issue, but it would be really cool.
Yeah, this topic is so complicated, right? It's there are a lot of people having PhDs on this kind of topic all the time, and it's very complex. You can list a lot of things that you can do to increase protection of the system. One is reducing exposure, and yes, do not connect them to the internet. You could have a local network or even just Bluetooth or whatever you have, and not have that exposed to someone waiting for an attack or something. But eventually you're going to want to have some kind of connectivity. And it's always a trade-off. It's always a trade-off. It's how much you want to give to the world to get back some kind of something back. And it's going to be always like that. You can increase all the, this is the thing about hacking, right? You can have, it's like natural selection. We can increase the system protection as much as we can. Eventually there's going to be someone out there that's going to know how to exploit some issues. I think that the key thing that we need to address is always be on top and think about things that the smartest people out there are going to be thinking of. That's why it's not easy. So we need to make reports as well, so we don't have time for all the things. So it's kind of complicated, I think.
I can miss something else. Go ahead. I'm not sure how much I'm allowed to say, that's why I'm shutting down, but imagine this. So if you write your software as a bunch of components spread out in this room, say, if each of them has limited knowledge and doesn't presume that it's connected to anything, but has something to do. So its logic is based on incomplete knowledge, but it has something to do. So it reasons based on that. And whenever it gets connected to others, it communicates and updates and whatever. So you always have incomplete and outdated knowledge, but it doesn't matter because humans do that and they function nonetheless. Okay? So you don't need connectedness to work. So that's as far as I can go with my research.
Here's an example, something that excites me is, or at least is interesting to me. I mean, we're so used to our devices, our computers are either plugged in all the time, we recharge them all the time. But if we have truly embedded systems in the sense that it's either really widespread, let's say you're a farmer, right? And you've got 50 acres and you've got stuff spread around there. And you can't go out there and recharge, 100 devices every day, right? You have things, embedded in a wall or some other place where you can't get to them. But you want things to run for years, maybe at a very low bit rate, and you want them to talk. Because, why have the sensor or the device, if it can't talk, it's just sitting there doing nothing. So those are the kind of things I think is going to enable a whole set of kinds of functionality and interesting tech that we're not even thinking of today because we're so used to having devices that we plug in and recharge. C++, just to kind of get it back to that side, because we have it gives us more of that control and that determinism and allows us to more efficiently use a battery or whatever it is that we're doing, gives us an advantage in that space. I'm sure there's other things that do too, but those are the kind of things that I'm not sure that a lot of people are realizing right now that get enabled with things talking to each other, whether it's to the internet or not, that we're not even doing right now. So that's my last comment.
You know which language is very good at that? JavaScript.
Oh, yeah.
Yeah, it's not what I use, but with Node.js, if you benchmark the thing, it doesn't catch on. It's impressive in terms of resource consumption. It's very low. Yeah. But it works.
Okay.
Much better than others.
Okay. My question is about communication protocol. So
easy questions.
Okay. Things mean that devices, sometimes gateways, need to connect to internet. Internet means servers on cloud, something. So what kind of protocol you using? So I'd like to, sometimes I'm using MQTT. So I'd like to ask a question for panelists and audience. How many people using MQTT? Please raise your hand. Those are people. I'd like to ask why do you, some criteria of choosing a protocol, sometimes use MQTT, sometimes a little bit heavyweight, but HTTP, TCP on custom protocol on TCP, UDP, yeah, many kind of protocols. But how to choose the protocol? My question.
I like this. I had the protocol conversation yesterday with the director because I think protocols are almost like the languages. You use whatever is appropriate. For example, in our SDK we have MQTT, AMQP, and HTTP. And we give the user can decide which one everyone uses. But I said, hey, how about instead of having the user decide, we can say, hey, what do you want to do? And then we will let you know the best protocol for that. The AMQP, if you want to do multiplexing, you choose AMQP. If you're working on a small device and want to memory constraint, we use MQTT. For HTTP, if you're behind a firewall, you only have the one port. And so there's a lot of different. So I say you use the protocol that's appropriate, and it is intentionally vague for what is appropriate because it depends on your situation.
I'll just add to that, when you're looking at protocols, they generally fall into families. Characteristics of the family, distance for your radio, for instance. There's short range, long range. There's a temporal issue. Are they coming on, once every minute for a very quick burst, or do you need something that's more continuously connected and rapid? Power consumption is another one. Are you talking about a wall-connected device, something where the user can replace their battery, or something that's essentially energy harvesting and never intends for the battery to be replaced? start looking down those dimensions and then find the protocol that matches that characteristic. And there's enough of them out there, you'll find something.
If you're working for urban settings or ubiquitous stuff, what you want to do is be adaptive, because there's so much of it outside. So one of the things you can build to architecture is something that adapts, whether it is that you're learning the protocol or downloading the components to work or what have you, but there's a lot of things outside and you're going to find surprises and new protocols coming up all the time. So thinking forward means adapting.
In that vein, actually.
Another easy one.
Oh no. So MQTT, there's sort of a souped up version of it now, which is MQTT SN, specifically for sensor networks. It's an SN version. And its big thing is auto discovery, because as we're flooding, especially industrial spaces with all these sensors and things, nobody wants to sit there with their console, cloning a bunch of device profiles and things. So the idea with these auto discovery family of protocols is that they can all find each other and it just works. In that vein, in the discussion a couple of questions ago about security, first of all, I'm sort of dismayed to find out that we don't actually have the typed IR group anymore. Because the compiler absolutely can help with that kind of security, the same way that the sanitizer works, idiom recognition. We can definitely build smarter compilation that can identify a bunch of dangerous practice and sort of sniff it out. This smells wrong. But to enable all of that, value-oriented programming, which is kind of what the C++ type system is geared toward, helps, right? Because if we don't have a type that we can argue about and reason about in the compiler, then, if it's just a bunch of pointers, good luck, right? So that level of security, if you're really worried about it, all of those kinds of sanitizer technologies really are key to using types to mean something. So that's definitely a strong argument for C++ and exceptions, since those type systems don't work without exceptions. That's why people are adamant about exceptions. The C++ type system doesn't actually work unless we can throw out of a constructor that can't construct. And if operators, we don't have the option of increasing the range of an operator return in many cases, and we can't all just invent a new man, so the operator has to throw. But by way of into this, one of the advantages of IoT for security, and I think it's something that people overlook, is when we have all these devices surrounding us, one of the big areas of danger is not security flaw, it's working exactly as it's supposed to. It's just that we didn't think it through. So the car is going to definitely get into the parking spot. It doesn't matter how many, baby carriages happen to be in there. So one of the advantages to sensor networking in particular is that they can keep systems honest. Right? I work in industrial IoT. If you have a bunch of networks of sensors all watching everything, then a system doing the wrong thing, either because it's been hacked or because it's just been programmed the wrong way, can alert other systems. Right? There's something wrong with the conveyor belt. I'm not a conveyor belt robot myself, but I can see it. Right? So the answer that I usually give when people complain about, by the way, the answer to going down to the market on an errand because your fridge told you to is don't do that. I strongly believe that is not a use case. But when people complain about IoT being dangerous, it's like, well, yes, but it can also increase safety. It's just a matter of how we design the standards around these things. So I guess my big question is, who do you see as the standardizing authorities emerging in this space? Who should, so I'm an architect for a company.
Please, no. I want to know which consortium should I join? Which standards group should I sit on the panel of that?
There's an ISO one that just started recently, so you should get involved there. There's an ISO group for that, and it's less than 2 months old. It's very, very young. Just for the constructor exception thing, there's a feature on P0484 that we're fighting for on SG14, where there's a feature that people want to have in threads that might involve adding constructors, in which case failure reporting would involve exceptions. You can also do it with a factory function where you will get something like an optional thread or something. So there are other ways to do things. You're not stuck with the single constructor thing. We have other ways to do that. For those who don't like exceptions, there are solutions.
For any specific thing, you can find a way around it. But if you have a do-nothing constructor and a bit function that returns bool,
That's just that.
I will find you.
That's just that. Don't do that.
Hi. I also have a security question, actually not...
Go back!
Actually not about probably the high-level errors in the code, but let's say you told not to connect to internet and use Bluetooth, but there was recently the series of vulnerabilities disclosed, like Blueborn, and I'm afraid to turn on Bluetooth on my phone actually now. So maybe you can say a couple of words. What do you do? What standards do you use? What procedures? And what is like maybe bug bounties or incident response and stuff? So I guess Microsoft should use SDL for that, but maybe you can tell us more.
Pigeons?
Every time you look, you're hearing on the news, somebody else is actually doing another, we have another exploit. You hear it often. And I think the problem is that we continue to, we continue to evolve in this space. All the things that they're adding to the C++ compilers to actually get smarter, and actually it's not just all the compilers are getting smarter, getting better. But that still doesn't, we have the human element. We have bad design, that we design ourselves into these things. We're like, we didn't think about that. I think it comes down to we have to evolve to be better in all the designs that we do, in how to make the IoT space a little safer. And we also have to say, hey, there's a caveat. You kind of expect that. Hey, you might not want to hear this. You might not want to turn on your Bluetooth and have it just on all the time. So I think we will always look for the magic bullet to say, okay, this one's safe, and now everybody can just write bad code, and I don't think it'll ever happen.
Yeah, so I'm going to give a little bit of a historical perspective on this. I taught a class years and years and years and years ago when the internet was first coming out. And there was just extreme paranoia over putting your credit card on the internet. Okay? Up until that point, there had been a couple of minor hacks. Nothing like we see today. Equifax, Target, 3 or 4 others I can't even think of off the top of my head, but very major hacks that have occurred just in the last couple of years. People still do it. Bad things happen. They get fixed. The world gets a little better. We now have, at least most of us probably have credit cards with chips on them. I suspect this is going to continue. We're going to continue, just because of technology being what it is, engineering principles being what they are, and the fact that we need to learn as we go, we're going to make mistakes. There's going to be some bad things happen. Hopefully not enough to offset all the good stuff, and then we'll fix it and go forward. I guess my advice would be, don't worry about it too much, but worry, don't do things that, directly expose you. Be thinking about what the impact of things are. Like, for instance, to the credit card thing, I just don't store my credit card number on the website. I put it in every time. Okay, it's a little bit of a pain, but it cuts off that, some of those vulnerabilities. When it did get picked up, Guess what? My credit card company was great. They said, oh, sorry, fixed it, it went away. You know, so there's multiple layers of these things, and we as a society build that in. So be thinking about the whole thing end to end.
Sarah would know more because she's playing with actual robots all the time, but I'd add a caveat to that. If you're gonna be hacked and you know you're gonna fix things, it's fair as long as not your braking system in your car. So you do need a fallback of some kind.
Yeah, I think it's part of the, I think you have to think about it like from the get-go as part of your architecture of like we deal with kids, right? And so this is like a very sensitive thing, like people's kids. And so in order to connect to another JoulBot, you have to be within 2 feet of physical proximity, and you have to like put your finger, you have to like, there's a input that you have to be a part of. So you can't just run around with a Bluetooth phone connecting to JoulBots. And like early on, a lot of people were like, well, you should put GPS in the device so people can find their kids. It's like, first of all, like wash your kids, and second of all, like no, because we don't want to enable like a GPS. Like yes, we would do our best to build security into it, but worst case scenario, someone hacks into it. They have a map of all the kids in like a 3-town radius. That's awful. So like I think a lot of these, depending on what you're building, like just making it impossible is maybe a good method of architecture to just like consider these things.
The other day, I had a meeting with people, with our security team in MSR, who are, they're vastly smarter than I am about this stuff. And we asked them, so, okay, we're going to build this new IoT thing, and it's great, and so we're going to make it secure. And they said, well, you're not. They said, you're probably going to get hacked, but what you want to do is minimize your exposure. If somebody hacks into a device, they have that device. They don't have your system. They don't have your servers. So that's the advice he says. When you design a system, make it so the individual device that you get only gives up itself. It doesn't give up everything else. And so I guess minimize your surface area, and that was his advice. I was like, oh, okay.
Thank you. I'm glad that there are exact measures to fight that.
I think a lot about Dan's talk from last year.
It was so good.
Regarding the cultural divide between C and C++ developers. I'm just curious how you all see the current state of C++ in the IoT space. How common is it to get to use C++?
Depends on the system. If you're on a big system that's like an ARM and you've got an OS, do it all the time. If you're on a little microcontroller, don't do it at all. That's generally what I see.
I can if you want.
Where at my lab, most people use Java because they don't know anything else. My own stuff is much smaller than a JVM, it does much more, but it's C++ code, and I wouldn't go back.
I'm seeing a lot of C++ code. We wrapping over our C APIs, see a lot of that, but I also see people use bare metal C. So I see about 50-50 when it comes down to it.
Yeah, it's like it's very easy for someone that uses C++ to go there and use whatever we have in C99 or just bare C. So, but we don't see people that program in C going towards C++ that much. I think, at least not my experience. But that's it. It depends on your system, and you need to be ready for both. Because we're not the users of these technologies, right? We're the ones that are developing things that other people are going to do. So for us, we need to actually have one foot on each side. So we don't have an option. And there's no conflict per se between C and C++ as far as I can see from our customers. People in the same group, they have different projects and they're using different languages, C, C++, and that's it, and they don't have much trouble. There's not a competition like, oh, this group is better than that one. No, my system requires this. This group has skills for developing that, and that's what they're using. The other one has constraints, they will use C, and it's an area that is very objective. People don't spend much time, oh, Node.js or Python or C# and Java. No, it's like, this device, these are my requirements, this is what fits, and that's what we're gonna do. So we're pretty objective on that.
I only work on one device, so.
I don't know, honestly. One of the reasons why C++ is attractive as a language is all of the ways in which it helps you be more certain that your code does what you think it does. C is much more, whip it up. And you have a lot of control and it fits in small spaces, but the compiler can't do that much for you. And that's the whole kind of the point of what we wanted to. When we're talking about a lot of embedded stuff, like I write all C++. When
I'm not really going to hijack. I target really small platforms in many cases. We don't use anything but C++ because the cost of the program being wrong in some way that we could have detected if we had written it in C++ is overwhelmingly the correct factor here, right? So I think that the more that it's mission critical, and I've got stuff running that's medical, and stuff running in avionics, and stuff running in nuclear power plants, and there's regulatory questions that I don't want to have to answer in front of a jury. So yeah, I want to be able to say I did everything a reasonable person would do, and I'm really not sure at this stage here as we're releasing 2017 C++, that a reasonable person can say, if the C++ program would fit and gives you the performance and everything else, it's almost not defensible to write in C with these things, if the compiler could really help you.
If you work with that and if you have the skill set.
Well, if you don't have the skill set, please don't write hard monitor.
There are a lot of old people there programming just in C or in devices that only allow that. So I agree with you, but it all depends on what you have on, what is your ammunition there, what are the skills and what the group can do. So, but there are lots of other things, like we're talking about languages like C++ has lots of stuff, and exception handling is beautiful, right? It kind of gives you like a peace of mind. But there are a lot of other things, like for example, we have like all the kinds of stuff like testing and mocking and making sure that we have requirements. All the requirements are discussed by a group of people that have been doing this for 300 years. And we also run like lots of tools to try to catch up on failures that we didn't see, like Valgrind, if you know Valgrind, for example, or Helgrind. So we can kind of see if there's anything.
Or you could use client Santa, which can actually understand the context of all of so the background doesn't understand.
That's another one.
Hi. So yeah, there are definitely cases where you have no choice but to go super duper tiny and live with typing word type def a whole lot and use C manually. And there are cases where, honestly, even C++, like if you really want to be all kinds of type safe, then write it in Haskell. And 20 years from now, when you finally get it to compile, it'll be perfect.
Let's go back to the topic.
But our data scientists are incapable of being divorced from Python and R, right? And they want to do edge-based learning and all kinds of stuff. So we make these big fat edges so that we can run Python on them. And so there are other cases for sure. I'm just saying that the case of correctness, I think, needs to be weighed pretty heavily.
No, leave the mic with that, because I want to follow up when you're talking about your usage of C++. What I'm curious about, in fact, maybe you could come here and I'll sit there for a moment, because what I'm wondering is, do you have well, maybe you have some formal standards about this, but I suspect from the way you've been talking that I would describe that what you do is you use C++ with a certain amount of restraint. That you have developed an instinct over what is an appropriate way to do it in a resource-constrained environment, like a microcontroller.
Right.
There are just certain things that it's not like we have a hard and fast rule not to do it, but we have learned not to do certain things. Would you characterize the way you program that way?
I would, but I'm not sure that that's unique. I think C++'s big problem is that it makes a bunch of things invisible, and but that doesn't mean you're not responsible for knowing that it's doing them. Right, so C, you see everything and you have to remember to do it. C++ will do it for you, but now, you might write something that's not performant. So yes. But honestly, my C++ client, not that many years ago, was returning all of its strings by default. Right? I mean, it's a rookie mistake. Yeah. But that level of C++ is everywhere.
Before I get to my question, I'd also like to inject myself in this debate.
Then you should be around them, facing this way.
Yeah, we'll have to face the camera.
Oh, crap.
Which way do I if you think about C as, except for some crazy stuff like implicitly cast avoid and stuff, a subset of C++. And if you turn off all the things that are on by default in the C++ compiler and off by default in the C compiler, you essentially get pretty equal code gen, right? Like, there's canary objects in the C++ compiler and exceptions in the C++ compiler and so on and so forth. And then you think, okay, I have this general purpose code generator called template metaprogramming that I can generate C code with. Then arguably I can generate better C code with C++ template metaprogramming than I can with C, because there is a certain level of ugliness, and this is a super high bar, right? I've seen code bases in C embedded programming that had more macros than non-macros, right? But there is some specific level of ugliness that people will not pass, right? But if this is the output of a template metaprogram, then this is suddenly okay because the user does not see it. And I implemented a library which essentially takes hardware register interactions as expression templates and then runs an optimizer within the type system, a template metaprogram optimizer, and then generates the register interactions, because I know more about this chip than the actual optimizer does, right? Like I read essentially the files that were meant for the debugger because I have all the information about the registers. So I don't buy into the argument that C is more efficient or creates a smaller flash footprint or whatever, because you can beat C programs by an order of magnitude in some cases if you give the user an interface where they can think in their mental model about the problem, and then I can just completely transform it and use things like, I don't know, bit banding to be atomic, which nobody's going to write in their code. And you can look on GitHub to see if people do. Hardware vendors provide this, but nobody uses it because it's just a brain fuck. Sorry. But if you put that behind a sort of code generator-ish interface, then it works again. And I mean, sure, there are counterexamples. If you don't turn off everything and you go, or in some boost libraries, even if you turn off everything, turn on LTO and use boost to upper, it will fill up your chip, right? I mean, there are these horror stories, but that's a problem with libraries, and it's a problem with tooling and so on and so forth. It's not a problem with C++.
Well, and the inliner is a great example, right? So, sorry, the inliner is a great example. Like the poster child for this is QSort. Right? You actually, because we're inlining and injecting whatever the strict root comparator is, that becomes, we strip out all of the preamble and everything else, it's a naked call that gets optimized away, and it winds up just being a register operation, like simple comparisons, right? So that's not just faster, it's also smaller, and it's not attainable with C, and even if you could figure out how to do it with C, it wouldn't look good. So, programming in a, I guess what Dan was thinking about was kind of a restricted C++ style, you can still get a lot of the power of a much more powerful compiler.
And the counter argument to that in the C community is that we can't trust people not to use all these language features that would be less efficient. And the counter argument to that is you're trusting people to do point arithmetic on void stars, but you don't trust them to not use virtual functions, which you
programmers
can.
don't have code reviews, so there.
Yes.
Well, okay. The problem with endeavoring to make it possible for idiots to program is the terrible danger that you might succeed. I don't mean to be dismissive. It was obviously for the joke, but not everybody is going to program IoT in C++, and not all of IoT needs to be written in C++. That is true. So we are already talking about, like, you have to be this tall to ride, right? And only because this is the nature of the problem. So then goes saying, well, but now we have to find these kinds of programmers that are hard to find. It's, well, yeah, but VC is currently bazookaing money into this, right? So that's why. So you can go get all those guys.
And now for your question.
And now for my question. I don't just see it as a security problem. It is also a reliability problem, the IoT. Like, I disconnect and reconnect my Amazon Fire TV stick more than once a week, right? Hard reset. And this is just kind of ingrained in our minds. Oh, it's screwing up, hard reset, right? Like, kids do this. Like, we know how to do this. But as soon as it's a light fixture, or it's my thermostat or something, like, what do I go down to the basement and like turn off the breaker and turn it back on whenever my light fixture screws up?
Like all repetitive tasks, you should automate the reset.
Yeah. Well, that's what watchdog timers are for, essentially. But the question is, like, what is the stimulus that you watchdog it on? And yeah, but there is sort of the typical always up systems, like somebody mentioned, controllers in the automotive field. That's basically throwing man hours at the problem. Is how they kind of deal with that, right? It's the man hours per line of code or a unit of features or whatever, however you want to measure this, is just terrible compared to app programming, whatever. And it's not just a question of cost. I mean, if we have some unit of IoT technology we want to develop, then even with unlimited money, I don't think you could find the amount of programmers to do it in the way the automotive industry is doing it. Do you see a need or a pathway to develop things, to change the way we program to a certain extent and change the way formal proofs work to a certain extent, that we can actually have tooling that proves our code in a more formal and sort of actually built on stone and not on sand way?
That is a good one. That's a good question. Yeah, actually, I would love to see that. Love to see, hey, there's a way you take it, you compile it, and you put it in some tooling, and it just runs and constantly runs, and then runs algorithms against your application to prove out whatever, and assume it's a black box. Now, with that said, that is that would be extremely difficult to to do. It would take, because they're it's so, IoT, the whole IoT space is so different, each application be different, and so now you have to take, you'll have to have a program to run the tooling so it can, so it knows what to do. Like, you do a plug-in model, you plug in your what it needs to do, and then call into your application. I think that would be an extremely useful a product if I ever see. But
I'm sorry. It's exactly what I think. Yeah, sorry. I really don't want to plug anything, but like my company, that's exactly the same thing that you said. That we really need to be more in a position of provably correct for these things. Mm-hmm. And C++ is great, but it's not actually able to do that, especially because, as soon as you escape the value semantics, right, and you're an object town, there's really not much you can do. So that's what I've been doing for the past 3 years, is building a programming language and compiler and so forth that uses a flow modeling language, so sort of like you would do it with Spark in the cloud, but small, and it's a functional reactive style programming language, so you write patterns. It's like, here's my sensor stream, I'm looking for a pattern that matches this, and we find arguments out of the pattern and execute a function, and then that output becomes, pushes downstream. And at no point are we out of value semantics there, and we can reason about it and prove. And the nice thing about that kind of pattern matching is that it compiles down to a state machine. So it runs like a mofo, right? Because it's just got a state table. It's small and fast, right? So not for everything. There are a few things we can't do as state machines, but the compiler is pretty good at picking it apart. So I think, and we're not the only company doing these kinds of things, right? But I think this is where we have to go.
Yeah.
But all that machinery is in C++.
Yeah, it needs to be. I think that it is needed because of course testing always gets pushed to the back burner. Oh yeah, we'll get it in. It just we don't have time for it. But I think it is if we had more of this, we had more tools.
Actually solve by constraint and say, no, really, the range of this function will never go outside.
Yes.
And one thing that helps is better practice, and that comes from education.
Now that would be the cheapest way, right? I don't remember. I would like to remember the name of the tools that I researched like some 5 years ago. I was working as a tester only before, and we researched, and there were lots of tools already out there that work for generating tests, like extensively, that could test your system in the ways that we could put like 10 people working non-stop, but we wouldn't be able to write those many tests.
Google's here demonstrating their fuzz testing framework.
Yeah, but they were so expensive because they are answering the billion-dollar question, right? So the practice and learning how to write secure stuff is going to be always the cheapest way, I believe. I don't know if these days, like how much your system is going to cost when it's ready.
Well, I mean, the Google one's free, right? It's a open source. Mm-hmm. And fuzz testing will only get you so far, right? We can run a billion cases that don't fail, and it doesn't prove a thing about the billion first. And again, because of the machine learning aspect of working in sensor networks, I've got the advantage of having a machine learning data science team. So we can mimic, expected sensor behavior and then fuzz it. So, we can say we've proven this, we've run it for a big burn-in with a bunch of, statistically useful fuzz data, and nothing bad has happened. Right? And bad in this case can mean not just that it didn't crash, but that it stayed within its operational parameters for latency and variance in latency. And no one ever talks about variance and latency, but honestly, that's the more important thing. But if you're going into industrial situations, right, these guys want a spec sheet, and tolerances that they can believe in, and they don't like software because it's so mushy. Right? So being able to, yeah, exactly, it's cute. But being able to produce all that stuff is not what programmers are used to, right? Especially app people, right? We don't, which is why, honestly, every time someone says, let's do it in JavaScript, some little part of my brain is screaming like it's being dragged down the hallway to the asylum. The guys who are going to do this in JavaScript are going to do it the way they do stuff in JavaScript. And it's really, really far away from demonstrable metrics, even though you're right, the JavaScript engine, V8 and all that jazz, they're actually quite good.
Measurably, it's much faster than competition, apart from this.
And absolutely, except that if we're worried about people writing, returning a string by value in C++, what kinds of monsters live in the JavaScript IoT system?
Yeah, I'm gonna go for it.
Yeah, this is gonna be the last person, so make it good.
There's a lot of discussion about security issues and issues in general, and things that we're asked to do things that maybe we disagree with because of monetary reasons or performance reasons or whatever. It seems to me like there's a lot of potential for either a subset of C++ that is C++ for IoT that could be standardized, that would provide frameworks for interacting with devices. And it seems like that is something that might need to be discussed.
So I'm going to hit that one off the top. So we have it's not really a formal, nobody's written a formal spec on this, but you come across the term embedded C++ quite frequently. And this means different things to different groups, so I'm going to start with that, and let me just drive that home further. It means radically different things to different groups. Generally, however, what I see, no RTTI, no polymorphism, no templates, and no exceptions. Those are the four I most commonly hear. Now, when you go to actually implement that, no templates. Does that mean no STL? Okay. No, no polymorphism. Well, that's kind of fuzzy. So that can save you some things.
Do switches count?
Yeah, right, exactly. Exactly. What's the trade-off you're making there? So, we just recently did some of this where we started a project and we spent a good couple of weeks actually debating what is, embedded C++ going to mean to us for this project. It seems to me that the industry could come up with a better standard and better terminology around that, so that it's not just a, embedded C++, yes or no. It's level 1, level 2, level 3, and then you can make, some trade-offs around that and have pretty well documented guidelines for people when they're making those trade-offs. These are the implications.
Well, I know that Patrice and I, and even Odin, is on the SG14 commit or group study group. So we are very interested in trying to bring embedded into that because of the latency issues that we're trying to address. And also, again, as Lloyd had said, there's some of these things like no polymorphism, things like that. So basically the standard is saying what has been done in the past that everybody's done that we can start standardizing. So get involved in that.
I was just looking up because I was curious if it was still out there, but in the mid-1990s there was a consortium of semiconductor manufacturers based in Japan that actually came up with something they called the embedded C++ specification. And it gained enough popularity that a number of compiler vendors actually included an embedded C++ switch in the compiler, which had the effect of disabling certain features. That's really what it was. It was a subsetting, and it was specifically 7 features, which they listed, were on the hit list. See if I can remember what they were. They were RTTI, exceptions, templates, the keyword mutable. It also included namespaces and the new style casts, and one more which I can't remember off the top of my head. It's well, whoops, I guess. And
The new keyword.
what?
The new keyword? No one likes new. Everyone likes mallow.
No, they actually, it was, the specification was full of holes, in that they never really nailed down a bunch of issues. And by the way, see if it's still there, I think. I'm gonna go back. So I actually Googled for embedded C++ Caravan because it's at www.caravan.net. Believe it or not, it's really still out there. And the reason I know about this is because if you look under the style guide on how to program an embedded C++, yep, it's the one I wrote. And
That's where this got started.
well, I mean, I did it as, you know, sort of on a lark. They had actually asked a colleague of mine, Tom Plum, with whom I had co-written a book, if he would do the style guide, and he was too busy, so I said, I'll take a stab at it. And I kind of regret having done it. But the political aspect of it was, this was something that Bjarne Strostrup vehemently opposed. This kind of subsetting was something that he really thought was a bad idea, and part of the direction that C++ pursued after that was to try to make this sort of thing unnecessary. And so I think that the idea that we would try it again with a slightly different domain like IoT, I think that's very unlikely to happen. I think that the proper solution to this is that people in that domain develop their own style guides for their projects that say, based on our experience and the combination of tools that we're using, platforms for which we're targeting, we encourage you to stay within this set, but the idea of having a rigid language definition, I think, is not going to gain much traction.
I want to thank Dan Sachs for existing. And apart from the fear FUD thing that we heard before for the old embedded thing that makes no sense, WG23, the Programming Language Vulnerability ISO Committee, will co-locate with WG21 starting at WQRKey as much as we can at the very least. The tradition that they had was trying to point out the flaws in languages. Since the advent of the GSL, we'll be trying to promote proper, efficient ways of doing things in C++. Because you can always do dirty stuff, but you don't have to do that. You can be efficient in making. So the goal is to promote good practice, which really solves a lot of things. Please do not remove the new casts. It will just hurt performance, don't do that. Please don't remove templates. It's based on myth from 20 years ago, maybe. Don't do that. There are other ways to do things.
It's just intuitively the wrong idea to go forward by going backward. We want the better compiler, not less.
The seventh one was multiple narratives. So as I said, it makes no sense.
Okay. Well, also with the advent of newer hardware, you know, some of these restrictions aren't there as it was back in the 80s and 90s. And so with that point, thank you all for coming. I hope that I know that we had a heated discussion, but not heated, but a very lively discussion about this. And if you are interested in having us do this next year, please let me know. I work with John, and we're trying to do this promotion of how user groups can do these kinds of activities to help spread the word about different technologies and C++ implementation. So thank you, and have a good night.
Thank you very much.
Yeah, I wanted to say,